team. Good morning.
Hi, Anand. Hi, Vasundhara.
Yeah, good morning, everyone. Just a minute. Share the screen. Yes, so software installation done. Any question or any issue you are facing in that?
No issues, Vasundhara. It's done.
Okay. Pratik?
No, Vasundhara. It's pending for me. I will do it today.
Okay.
Yeah, I will let you know if I face any challenges.
Yeah, sure. So, right, we will start the pendings today for warehouse and probably the warehouse will complete. Yes, so we have learned up to now the facts and dimensions. Can anyone explain what is the difference between star model and snowflake model?
Well, the star model is nothing but which will contain, one fact table along with that one dimension table kind of thing. Whereas when it comes to snowflake schema, it will be having again the dimension will have an internal another dimension table. And star, which will obviously will have a less data redundancy, and then snowflake will have I think no. Star will have more redundancy, and snowflake will try to reduce the redundancy. Yeah, so these are the major differences between star and snowflake.
Okay, which one is in which one the dimension is further normalized?
So I think star is not normalized, and snowflake is a dimension.
Pratik, can you try to explain?
Not sure, Vasundhara. Need
Yesterday
to
only we
go.
covered. Yeah, any one line definition at least.
I need to go through it again.
Okay, fine. Please, whatever we are covering daily basis, do the practice, and at least that much you should be aware about. Okay, today is Tuesday, I think. Okay, this Friday I will ask all the warehouse concepts. Okay, so prepare for that.
Yeah. So
Star model, that means a basic dimensional model.
Vasundhara, sorry to stop you.
Hmm.
Actually, I wanted to discuss about this Friday class.
Yes, tell me.
So where I actually told, Ayappa Diksha, right? So this Friday only, I think we had to travel in the morning only. Uh, so most probably, not most probably, I'll not be able to join that one class in this month.
Okay, so should we schedule on Saturday?
No, this Friday, Saturday, Sunday, these 3 days I'll
Oh,
not be available. After that, any weekends also I'm fine.
okay, sure. Then next week also, Friday it will be there. Every Friday, I will take some 10-15 minute the
Yeah,
revision or
please, please.
question answer session, doubt solving session, and then normal things will go on like that.
Sure, sure. Thank you.
Okay. So, what is the star model? A basic dimensional model having fact tables surrounded by dimensions. Snowflake is also a star model in that dimension table is further normalized. In layman terms, divided. Normalized means divided. Okay. What is acid property? That you should make notes otherwise and remember that all. Okay, fine. Now, we have learned types of, or we have learned dimension and fact. Can you tell what is fact? What is fact table content?
I think it contains no fact, mm, measurable information like yeah, I think it contains fact table contains a measurable information.
Mm-hmm.
Whereas dimensions will be having descriptive data.
Subject oriented data.
Yeah, yeah.
Dimension have subject oriented data. Fact have facts,
Fact
measures,
is
as well as,
transaction oriented.
yeah, it has keys also. So, whatever we are learning, now learn it properly, guys. Anytime I can ask anything. Even when we are doing ab initio, I can ask some relevant concept. If it come there, then I will ask. So, don't make it pending because it is not college exam that you will learn when exam is there. So before that, right? In for crossing interviews, one need to prepare every time. Anytime they should be able to answer. That's why I
Yeah.
used to ask anytime in middle or anywhere. So what is the fact actually? Fact contains, yeah, we have learned this much only that it contains the keys and that is fact contain keys and facts. That much only we learned. So we will learn today it contains much more than that. 2-3 things more than that. Not much, but few more. Mm, yeah, here's fact table. Yeah, this is fact table contains first all dimensions keys. This example we have seen that there is a customer, product, time, and store dimension, and there is a fact table. So it containing bill ID, invoice ID, all these keys. These are keys, right?
Yes.
Up to here, time, product, customer, product, time, store. These four are what? Keys of this four dimension. And apart from that, it contains facts, total quantity left, total cost. These up to here, these are facts. Yes, and some extra things. What is this? This is not dimension, not fact. What is this? So we will discuss that also today. First is these are actually, this one is bill ID and all. This is degenerated dimension, and this one is junk dimension. So when we will learn type of dimension, we will see what is the degenerated and junk dimension. That is also inside fact table only. So fact table contains this four type of data. Mainly keys, it is compulsory to contain the keys. That is compulsory. Okay. Other things are optional. These are optional. So if some fact table which contain only keys, it doesn't contain any of facts, then that is called factless fact table. What is factless fact table? That contains only keys.
Which doesn't have a keys. Sorry, that contains only keys.
Only keys of dimension. That is compulsory, because otherwise there is no use of maintaining warehouse if that doesn't have any relation, right? If you need to be able to fetch the report later on, you have customer data, you have product data, time data, store data, but what is the relation in them? This fact is establishing relation, like this customer purchased this product on this time from this store by storing all the key in one particulars. Right? If this is not there, then who purchased what? It will not be resolved. So this is compulsory. It should be there in some table. That is called fact table. So if some table containing only this, nothing else, that is fact. Facts are not there. Only keys are there. These are facts. So if without fact only keys, then that is factless fact table. Then what are the other type of facts? So there is fact contain all dimension keys plus measures quantitative data. So there are four type of table: fully additive, semi-additive, three type of fact table are there: fully additive, semi-additive, non-additive. So what is fully additive? What is the meaning of additive in terms of summarizing or generating the reports based on measures? So these types are based on measures. Okay, there are other types also in detail vast, but these are the types based on measures. Like if you want to generate a report, suppose you have this data, this particular data of the inventory or retail warehouse. Like a mall is there, suppose you can imagine a mall. In that many clients visits and purchase the product daily basis. Many people visit and purchase the product, so they are doing inventory and then registering their information in the at the time of billing or inventory. They are registering all the data: what product, who purchased, in what price, total how many product purchased, total cost, total quantity, everything they are storing in some system, right? We observe this all in day-to-day life. And after storing, what the happen for the data? Daily at a fixed time, the data will be sent to warehouse, right? So those data are stored in this model. You can assume like there are four dimensions. There are many actually, but we are assuming for simplicity four dimension and one fact. So in this manner, data is stored daily basis. Dump will come, millions of record will be there here. Like I given only one sample record. Like that, many records will be gone. So this is some others bill ID, other invoice ID, another customer, and they purchased maybe same product or different product on same time or different time. Yeah, maybe from same store, and quantity may differ. Like this purchase 10, this purchase 30. Okay. Quantity left. Something like that. And the total cost. Okay, status ID is ordered. What is status ID? We'll discuss it. So this type of millions of record will be dumped on this fact table. And this all customer data, who is C102? That is data will be stored here in customer table. Like C102 or C101 is some name, a phone number, email. C102 phone numbers. Like this. What is P101? Right? That is a product. So similarly, for all the tables, this is the just a key. What is their name? You need to go to product table. Right? Product ID by P101, laptop, brand blue, brand HP, blue color, like that. P102, something else, like that kind of entry will be there in dimensions. So now if you want to generate the report based on this, if you have the data of say 1 year data, so millions of record you have, you want to generate a report based on this. Which kind of report? Product wise total revenue. So is it on this dimension, product dimension, is this report is valid and is it getting generated? This two question will be asked. So if you will ask this two question on fact table, then you need to see that product wise total revenue, is it a valid report for CEO or a stakeholder? Yes, it's a valid report to take some decision based on the how much profit happen on which product. For that, it's a valid report and it can be generated. You can do a group by query, grouping on product and do a summation of the cost, total cost. So you will get total revenue on the product one, right? The output will look like this. P101 total revenue, this some dummy data I have filled here. So P102 or P02, this much revenue, P0. So it's valid report and it's possible. So against the PID, the report is able to generate it. So against PID, it's additive. Additive means this report total sum addition of summation of cost is possible against this dimension. Against product dimension, this summation is possible. Right? So we will see against the another dimension also. Customer wise total product, 1 minute. Product wise total revenue. So product wise is okay. Another is total revenue if we want to ask for customer wise total revenue. So is that report possible? Customer wise means you can do a grouping on customer and that report is valid also. Like one want to see that from which customer the lots of profit is happened for giving them some incentives, gifts, right? So that is also valid report and that is possible here. Time related total revenue. So on which time limit or time duration, time limit or time in between this time to this time, these sales happen a lot. So either by time wise grouping you can do, group by query is there, by that you can do grouping, or even the range of time, that wise also you can do grouping. So that report is valid we to predict that in which season sales happen what of which product also, like that. So this is a valid report. And store wise total revenue, that is valid report, that is possible also. So this dimension total cost, this we will say it's additive against all the dimensions, right? So this particular total cost is what? Fully additive fact. These are facts. So which some can be fully additive, some can be semi additive, some can be non additive also. So this total cost is fully additive against all the dimensions. Now, if you will see total quantity, so is the total quantity is fully additive. So product wise total quantity sold, valid report, right? We need to see that how much quantity sold, how much need so demands are high for those product which is sold more, their demands are high. For predicting demand and supply, we can generate this report, and it is possible to generate. You group on this and do a summation of total quantity. Then customer wise total quantity uh, only alone customer wise total quantity doesn't matter, right? Total quantity based on customer, it doesn't give you the proper picture. You need to add two dimension here, customer wise, product wise total quantity. So again, product is given high importance. For total quantity, whose quantity it is? Product's quantity. So every time, even time wise total quantity is not making any sense, right? Total quantity of which product? Every time product will be involved. Store wise total quantity also not making any sense, because store wise also which product's total quantity? It's always coming in picture. Product is always coming in picture whenever you say total quantity or quantity left. This two parameter is related to product. So you can't generate report just based on customer dimension, like customer wise total quantity, how much quantity product a customer purchased. So C101 purchased 100 product, but just a biscuit packet, and C102 purchased 10 product, that is laptop. So we can't understand by anything by that, that which customer giving more profit, right? By just customer wise, we need to involve product for this. So that's why these are a semi-additive. Semi-additive means alone only against the product, against the product wise, the report is valid as well as generative. It's possible to generate the report, but against the other dimensions alone, it can't be generated. You need to involve some particular dimension on it. So also compulsorily, right? That's why these are called semi-additive. Is it clear what is additive and semi-additive? Facts.
Yeah, clear.
Okay, Pratik.
Yes.
Okay, same day, please make your notes also before forgetting. Make your notes and recall that next day or whenever I ask. So, what is additive? You can give example also for star model, snowflake model also. If in interviews also, you can give a rough example like this whenever it is asked. So, total quantity, these are semi-additive. You can remember the name of column. So, for giving example sake, you need to remember some examples. Then only, like concept also based on examples many times. Like mainly in this case of what is semi-additive and what is fully additive. Okay. Then non-additive, last. So non-additive means they are not additive against any dimension. Suppose there is a status ID also. This is also non-additive. Other than that, GST is there, or uh, percent of profit, or percent of total quantity minus okay, total cost minus discounted cost, something. So percent of percent of discount, or percent of loss, or gross profit, or percent of gross total, something. So total, gross total is can be additive or semi-additive. Gross total means some summation is there of total cost and some other price, extra price, or discounted is there, then minus. Okay, so that is gross total. And for that gross total, if you are calculating some percent, that is also no use to do addition against any dimension. Similarly, this status ID, what is this status ID? So instead of storing status here, like it is delivered, this 4 particular columns, delivered, return, cancel, received, 5, ordered. So instead of storing these 5 columns here, and it will be repeated like value will be like 10 bytes. So 1 to 5, 50 bytes. 50 bytes will be repeated here every time. We will repeat only 10 bytes, right? We will store it in some other dimension that is not useful, just a junk dimension, and we'll store a store ID here. So this store ID also not any additive or semi-additive. It's non-additive. It's not like you can product wise or customer wise status summation, no use, right? So that's why this particular is non-additive against any dimension. GST also, GST is this much apply, this much apply, for every product, this much GST applied. That is also non-additive. You no need to add for P101, summation of GST is no use. Discount amount also, like percent discount, 2%, 3%, 4% discount is there. So that also, total, on P101 total discount, how much happened? If 2%, then 2% only happen. Na? You can't do addition 2 plus 2, 4 plus like that. No need, no use. So percent discount, all these things are non-additive. This all. So semi-additive, non-additive, and fully additive. Any question?
Just one last question on this non-additive one. So, like you mean to say whatever the column that is there, right? For that, you'll have a different dimension table, which is like not majorly used, right? When you say not useful, majorly we'll not use it, but whenever it is required, we need that one as well, right? That same
Majorly means
dimension
for
one.
report generation, it is not that much used, because this is used for just for checking that, by clerical user, that it is ordered, or in which status
Yeah.
the product is, just for checking that purpose. It is not containing any data, like product is containing products data, valid data, useful data, but it is just containing a one-time junk data.
So they just want for a report to be generated, whether the status is delivered or not. That's it. Not the complete data of that. Okay.
Yeah. Only yes, no kind of um,
Yeah.
cardial, not non-cardial, like um, cardinality is there. So only repeated data, you can say duplicate, kind of only one value, yes or no, two values. Only two values are there for every column. That's why it is not useful data, just for report generation, or sometime one need to check the status. That purpose they use.
Yeah. Got it.
So this is a type of dimension. I will describe more. But this is also non-additive here. That's why I explained. Non-additive means, like suppose store-wise total status, no use. Like 1 plus 1, 2, 3, 4, no use at all. Not making any sense.
Got it. Yeah. Thank you.
Okay, so non-additive means they are not additive against any dimension. Semi-additive means they are additive against some of the dimensions, not all. And fully additive means additive against all the dimensions. Additive against valid represents all the example. Total cost, that is fully additive. Quantity left and total quantity. Sold. They are semi-additive and non-additive. So with these examples, you will be able to explain. That's why I'm using this existing notes, so that I no need to write. That's it. Yeah. Right. So I will share the same with you also. So you can prepare, but I have already prepared this. So we'll share. You can revise from this also, or your notes. If you will prepare your own, that will be more good. Okay. Then that concepts are done. Then next is types of dimension. So there are three types of dimensions are there. One is types of dimension. One is regular dimension, like customer, product, and all. They are regular. Other than that, there are Three more are there: junk dimension, degenerated, and confirm or bridge dimension. So junk dimension, we just saw status ID, right? Instead of storing all status like delivered, cancelled, returned, ordered, all this column in fact table, we are storing just ID for saving the space. Why? Because that is low cardinal. Low cardinal means what? Actually, this is a term in warehouse. Cardinal means that is unique, which on basis of that the report, no, sorry, relation can be maintained. Unique columns like primary key columns on which relation can be maintained, like foreign key primary key relation can be established with other tables. That is cardinal. And non-cardinal means, or low cardinal, or non-cardinal, or low cardinal, high cardinal, low cardinal, like that. So low cardinal means duplicate columns, like status ID only two value, yes, no. So yes, yes, like that only going to repeat. So duplicate same values repeating. Okay, that is that kind of column, like example is status, ordered or not, cancelled or not, returned or not, yes or no. So that is called low cardinal column. On or any flag, this is status or any flag column, like uh, in flag we will maintain the value active or non-active, right? Or at the time of soft deletion, there are some soft deletion flag also, like deleted. That means that they will just mark D. Data will be there. It's not removed from the table. Just they will just mark D. So soft deletion flag, soft deletion flag. So D deleted or active. Okay, like that. So these all columns are low cardinal columns. That is duplicates. Okay, cardinality is clear. Then we have seen these four columns just now. So they are repeating yes no value. They are low cardinal columns. So instead of maintaining them in the fact table here, we could have maintained them here also, right? Instead of status ID, we could have put ordered, yes, no, okay, and then delivered, and then all this five columns we could have maintained here. You can assume that instead of status ID, this five are there and their values corresponding yes, no, these are there. For every record, this value will repeat. So that much space they will occupy. So instead of that, we have separated them as a junk dimension and storing only their ID. So this dimension is called junk dimension. That is also a type of dimension. That is storing low cardinal values because that is repeating. And we are focusing in fact table that should like only unique value should be there. Fact, one more thing about fact is it contain unique values. Most of the time unique values, trying to avoid repetition, right? That is good for fact, so that it will not be that much bulky, and that query will not go that much time, it will not take that much time. For performance also, we are making the fact to avoid repetition. Repeated data we will store in something else, we will do some different use for that, but we will try to make it unique. Data should be unique, not repeated data will try to adjust in some other way. Okay, so that's why all this arrangement is for that purpose only, to making the fact less bulky and able to generate the reports with performance. For performance optimization only, we do dimensional modeling, right? We divide the data in this much things, and then the repeated things we remove, right? So this is all the definition of facts. This is complete definition. Okay. Then this junk dimension is clear. Any question in that?
No.
Okay, then next is degenerated dimension. So what is degenerated dimension is, just a minute. So degenerated dimension are opposite to this low cardinal column. There are some high cardinal column, right? Like status ID was repeating its low cardinal, but bill ID and invoice ID, if you see these two, they are also extras. Are they dimension key? No. Are they facts? No. What are they? They are degenerated dimension. That means they are also part of fact table only. Why we kept it in fact? Why we had not separated like status ID? Because they are growing with same pace as the fact is growing. They are unique. Every time new bill will be generated, new invoice will be generated. Generally it is system generated surrogate key kind of column. We will not say surrogate key to them because surrogate key has different unique use also. We will see that in SCD type 2. So these columns are called degenerated columns because they are not dimensions actually, but they are degenerated dimensions, we say them. They are not part of any dimensions keys. They are not keys of any dimension. Okay, they are complete dimension. This invoice ID and bill ID is one degenerated dimension and having only two columns, only key columns, doesn't have any data further. So we are not storing that data further in any other table. So they are dimension but a part of fact, that is called degenerated dimension. And why we didn't separated them? Because they are unique. So they are not repeating. If something is repeating, we can separate that out and only key can be stored, right? But if something is not repeating, there is no use of separating them out, and this key cost will be unnecessary otherwise. If you separate them out, the extra key cost will be there. That's it. So that's why we will keep them as it is in the fact itself. So what is degenerated? High cardinal column. They are unique column. That's why they are part of fact. And junk is low cardinal columns. We separate them as a junk and only kept the key. Is the high cardinal also clear, guys?
Can you repeat that one? Just like when you say
Yeah,
low cardinal, okay. When you say low cardinal, it is a duplicate one. High cardinal is nothing but the unique one, which will not have any further more dimensions, tables, kind of thing.
Yes, they have every time we go for inventory for any purchasing any item, then we go to inventory, then this bill ID get generated, invoice ID get generated, right? For every customer, it's new. Even you come again to the same shop after 2 hour, 3 hour, or next day, it will generate the bill with unique ID. It will not generate same ID, right? Every time new bill ID will be there, new invoice ID will be there. So these columns are not going to repeat in any case. Even the customer visit, the same customer visit again, then also. If same customer purchase same product also, uh, like that. So if same time he purchased many product, then one bill ID, under one bill ID it will be come. But if the customer visiting on different time purchase, or sometime and same time also customer separate the bills of different data, right? Different products. So at that time also two different bill ID will generate. The meaning is that bill ID and invoice ID will be unique every time. Every time unique, never repeat. That's why they are part of fact.
Yeah, got it.
So next is last is confirmed dimension or bridge dimension. Okay, so I need to show that. One second. So what is the basic dimensional model look like? Like there is, suppose 4 dimensions are there. You can imagine an online store and an offline store. Suppose 2 stores are there, and in that we are storing the data into facts and dimensions. So these are this is one model that is having one fact table here and surrounded by many dimension tables. So you can assume that this is customer, product, time, and store related dimensions, or like that. And this one is fact table. So fact one, and it is having its like time related fact or something. Okay, so that is having its own column, time ID and all. Fact also having its ID, and it is having keys of all other all other tables, and it has some numeric data that is called measures. Okay, so this is one model. And now if you have same model for offline store also, this is model for online store, suppose. And same model you have for offline store also. So if you need any kind of combined report, or if you need to see the audit, like both are in synchronization or not, or you want combined report on this is offline product sold, this is online product sold. So just one flag of offline online, and then it will in one report only both the data will come. So how to combine them? This is stored in one warehouse of this particular model, star model. Both are star model, both having same kind of, but data is different. Okay, it is having online data, it is having offline store data. Offline customer visited manually, online customer ordered on online and delivered online. So this data is different, but the structure is same. How to generate the combined report? Either you generate from here, and then manually merging of millions of record is not easy task. So what they do, they create one this dimension table. It is a dimension table. Its name is confirm dimension or bridge dimension. So it's not a fact table, it's a dimension table. And generally we have seen a fact is surrounded by dimension, but this dimension table is surrounded by facts. So this is such type of dimension table which is surrounded by two facts table. Okay, it is, if in your project you see such kind of dimension table which is surrounded by facts, two facts. Surrounded by facts means there it will have the key of this fact. Like suppose this is the F1 ID and this is F2 ID. This is the key of the fact table. It is having more data also. It's related to dimensions and all. But I am just considering key. So it will have both the keys as a foreign key. So these are primary key here and these are foreign key here. So up to now we have seen only fact table containing the primary key of dimensions, right? But if you will see any such table which is containing the primary key of facts as a foreign key in it, that is called bridging the gap bridging between two models, two star models. So bridging the gap between two star model, this bridge dimension table is there, also called confirm dimension for audit purpose also. They use for confirming that the both the data is in synchronization or not, like on same time, what how many cells happen online, how many cells happen offline. So they will do audit on that and check that both are in synchronization or different cells are happening, or what report generation purpose also, or for audit purpose also. So for report generation, it will say bridge dimension. For audit purpose, it will checking the consistency in both the models. It is confirming consistency. So confirm dimension. Right. So is it clear what is confirm dimension or bridge dimension?
That's clear.
Common dimension between two models, two star models, you can say. Yes. For bridging the gap, for generating report, combined reports. Pratik, is it clear?
Yes, yes.
Confirming the uh, consistency between two dimensions, right? Then so this is about the facts and dimension, and with that, maximum warehouse concepts are completed. So only the SCD types are pending. So what is CDC? What is SCD types? So in different stages, CDC means change data capture. So there is some staging table. They capture the staging table capture the CDC. What is the meaning of that? So last time we have seen that there are different staging areas are there, like raw data staging, right? Raw stage, and then processed stage.
Yeah, we have raw, processed, the presentation, and then golden layer.
Presentation layer or stage, and golden layer, that means done, right? So in different layers, the data is getting received, right? So what happened, like if any new data is come in the customer, suppose some customer has changed the phone number. So at this processed staging layer, we can capture that changed data in some table. Some CDC table will be there. In cloud, it is some staging table. They auto capture immediately if there is a, and they will do a join between master table. Here in golden layer we have master table. Suppose customer dimension, customer master table. Okay, for customer table, if we see, if some customer has we received the data today raw data, some customer has changed his phone number. So what we will do, this model is just feeding the fact daily basis. Okay, that is different process that is going on its own time. But one more table is there, CDC table, that has joined the data, like customer table here on that. Here we are receiving, suppose delta load, daily incremental load. So it is having the big table like sales, India sales CSV, suppose table. So that CSV will loaded into this big table of India sales table immediately. And then after that, at the processing time, we have divided data facts and all. So at the time we have CDC tables that will load this data of current today's data, suppose 2025, 12th of December. So this is the complete table. Table name will be different actually. File name it will be. The data is loaded from this file. What is the file name? File name contains the date. You are working, so you might observe that that file name contains the date. So this CSV file is loaded into this table. This is new every time its raw table is getting reloaded daily basis, overwritten daily basis. A master table will not be reloaded daily. It is having all historical data of all dumps, but this table will be reloaded daily. CDC table also reloaded daily. So here after reloading, it will convert this data into customer delta, product delta. Okay, those tables, small table will be filled with this data. So what does CDC table do? CDC table join uh, delta and existing customer master table. So what is the delta? It's containing today's data, today 5 p.m. data suppose. And what is the master? It is containing all history, entire dump of so many years, right? So this is a huge table and this is a small table, today's data only. So what CDC table is joining these two and checking that these two are getting joined and checking if there is any change detection. If there is no change, then it will not capture that data. Change detection or newly inserted. Okay. So what CDC table is doing? It's just detecting the change and capturing. Suppose in master table, you can assume that there is uh, this example. There is a master table, customer table, it containing this data. Customer C101, name ABC, its location is Mumbai. And in today's Delta load, at 5 p.m. you received that its location is changed from Mumbai to Hyderabad. Okay, so what your CDC will capture? So it will join the master table, your history table, and Delta table, and will common records will not be captured. Okay, that will be rejected. Only newly inserted record and whatever is changed, those record will be captured here. So this file will be called generally they keep there are two things. One thing is they keep the data into CDC. One thing is this. Okay, all the change data, and later on they do this operation. What operation? SCD1 operation or SCD2 operation or SCD3 according to their requirement. They prepared such a graph, and according to that the dump will happen in the dimensions. So SCD is a slowly changing dimension, is a process for updating the existing dimension master table for newly inserted data. Okay, so that is what is CDC. It is capturing the CDC is the staging table that is capturing the data from the which data which is changed or newly inserted. Like if some new customer visited, so that also will be captured here in Delta load only. So these two customers are captured. One is inserted and one is changed his location. In master table, this is the data. It doesn't have C102 data. So we will receive all this data into Delta CDC table. Okay. After that, what we will do, we will apply either SCD 0. That means SCD 0 means no change captured and it's fixed dimension. It doesn't change much. SCD1 table is the which is having the latest data, and all the data will be lost. That means we will do such operation that this latest data will be updated here. This will be removed and replaced with latest data like Hyderabad location. It will not have history like before Hyderabad what was the location of the customer. It will not have that data. Master table will have only latest data. Okay, then there is another method SCD2 in that both will be maintained, latest also, history also. Then SCD3 in that latest and partial history. Why? Because when you maintain the history, it may be grow to huge data, right? So that's why for avoiding the bulkiness of the dimension table, we will store only partial history. So this basic understanding of SCD 0, 1, 2, it should be clear first. Let me explain further. What is surrogate key? We will come when we will learn more about SCD2. Yes, so type 1. Type 1 means overwriting a dimension attribute when a source attribute change. For example, first we'll see the example, then detail. Suppose this is the data of a customer dimension. Customer ID, customer name, status or state, address. Okay. Then if the particular customer has changed the location from New York to California, then your dimension, customer dimension is storing only latest data. So by seeing this, this is the master table, it is updated to this data. Now if we want history data like before California where this customer used to live, we don't have that. Okay, it is lost. So this is SCD1 method. In that overwriting dimension attribute when a source attribute change, in the source system. Old value will lost. No history prior value is maintained. Dimension is always latest and easiest to implement actually. When to use SCD1? When the old value is of no use for analytic purpose or in report generation purpose. So advantage is it's the easiest way to handling SCD problem because old information and history is not maintained, only the latest data is maintained. Disadvantage is history will lost. Okay, so by applying this method, what is the time? 1 minute. Yeah, we have. So by applying this method, it is not possible to trace back history. So in this case, the company would not be able to see the Krishna lived in New York before. Okay, so when keep tracking of history is not important, then only for those dimensions only go for SCD1. It is recommended. Then how to implement that?
Sundara, what would be any example for that SCD1? Like in which cases will not maintain that history data?
In which case, like in that cases that in which we are not want or the user doesn't want to involve historical changes. 1 minute. Yeah. So SCD1 means the historical data is not needed. So whenever in your business or in your product project on which you are working, if you detect some type of things like customer ID, customer name, email address, right, and phone number. So if somebody has changed his phone number or email address, and you don't want to store those values, generally, if somebody changed the phone number, old phone number will be assigned to some other person, right? So there is no use to maintain the old phone number, old history data. So that will be implemented using SCD1. Similarly, email address also, if it is changed, that means old email is, if second email is different, but if he is changing, then in that case, we are no need to maintain the old email which is lost or it is closed or something like that.
Got it. Yeah, got it. Thank you.
Then SCD type 2. So add a new dimension. SCD2 means maintaining history as well as latest also. Most of the cases SCD2 is used or 3 is used. And in that we generally for address purpose we use SCD2 or 3. In that we want the old address also for any kind of backtracking purpose that customer was staying on that location previously. If anything happened, then one should aware. Mainly in companies, if employee is working, then for employee data, they maintain the history also. Like the employee was staying earlier in that location or working in that location, and then he shifted to this location. So for those kind of column, they maintain in SCD2 relations. So add a new dimension row when a source attribute changing in source system. The new row has right. 1 minute. Now, how to maintain history now? That is the question. You have this data, data. You have delta means it is suppose today's data of this much happened, and this is old data. History master data means old data. So the ABC location, old location Mumbai, new location Hyderabad. CDE it's new customer, it's not there in old. So as per SCD1, what will change happen? This change will happen and this new customer will dump as it is. Old data lost, this customer ABC staying in, or if phone number changed, then new phone number like that. Now in SCD2, if in SCD2 we want
So
to
in
maintain
SCD1, the new location is what? New location is Hyderabad, right? Okay. Okay.
Yeah. So old location lost, right? In
Yeah, got
history
it.
lost
Yeah.
in SCD. But if we need to implement SCD2, we need to maintain history also. How we will maintain history? So for maintaining history, there are SCD2 and 3 is there. In SCD2, we maintain some extra columns. They are called SCD2 columns. They are what? Surrogate key, effective date, end date, and some flag for active, inactive. So these columns are called SCD2 columns. They are useful for maintaining history. They they make us to maintain the history. How? So if we see just by, we will see process later on. We will implement also this in ab initio. But currently, it's just to understand the what happening theory. We will understand theory first. So master table having master also having the effective date, end date, and surrogate key. So why surrogate key is important here? We will see that also. Already this customer ID is there, but why we need extra key? So surrogate key is, if we see the definition, surrogate key is system generated key. System generated means it's not coming from source. Like customer data is customer ID coming from source, but it's not coming from source. It's generated by system like in SQL, if you are aware about the sequence next val sequence generator, create sequence name and triggering that on every insertion. By that that ID or SK, it will be auto generated every time you insert the normal data. SK will generate auto by system. So that is one thing. Another thing is it is used for when surrogate key is needed. When the primary key is unable to serve its purpose, that means you can't enforce primary key constraint. It will definitely will be duplicate. Okay. When primary key unable to serve its purpose, that means forced to be duplicate. Forced that PK will duplicate or repeat. Like in our case, if you maintain the history of this customer, you need to maintain 2 record, right? Or I will not write here because it's SCD1. In SCD2, if you will maintain, then you need to maintain 2 record. One is Bangalore location or what was early location. Another is Hyderabad location. Also, so you need to maintain 2 record. Then for same customer, then this is getting
Duplicated.
right. So in that case, we need to maintain one unique key for maintaining the history that will not repeat. 101. This we need to compulsorily repeat because this is the same customer for that purpose. And next time we need to join, then we need to say that this is same customer. And that's why, sorry, this will not duplicate it. So that's why we maintain surrogate key that will never duplicate. So surrogate key is one more quality. SK will never duplicate. It's always unique and not null. So what is surrogate key? It's clear. Then next is effective date, end date. So this customer was staying on Bangalore location. Okay, this customer is staying on Hyderabad location. No, not making change. We need to give effective date, like Bangalore location from when to when. Suppose from 2000, from this time till today, we have received that it has changed location. So we will close this date, the old location with today -1 end date. That means 2025 12. Today is 2030. Today is 29. With that time, we will close it. And the flag is there that or status is there that will make it inactive. It's no more active in that location. It has worked from this 10/4 till 12/29. Not 10. 10 means October 4 till December 29. 2025. 2000 October 4 till 2025 December 29. Till that year limit only or time limit, date limit only, this person was in active. Now it is inactive. Okay, and now it is active in Hyderabad location. So 2025/12/30, that means 30 December. From this time, now high date, end date will be high here. That means currently still it's working there only. So it's active here like that. Same thing will go for this person also. It will have surrogate key and this data. So like this, we need to implement the logic in that manner so that it will have these extra columns: surrogate key, effective date, end date, and flag. So when we will implement SCD type 2 or type 1, this theory I will ask from you. Okay, I will not repeat there. You need to tell me the theory. We will do the implementation, this part later on in ab initio. Is it clear, guys?
Yes, it is clear. Yeah.
So same thing like we do join, then we capture the inserted or changed record, and then we do different operation for them. What is that? Detail we will see later on. So SCD2 means this kind of arrangement. New record, okay, so new row has a surrogate key. In the new row, change attribute have a new value in new row. So what happened actually? The existing data like Bangalore location, what we are doing exactly, we are just updating the master table or inserting the data in master table. Like in SCD1 also we updated this update table name. You are aware about SQL queries, so we updated this and this is inserted. Updation insertion only going on. So after joining in SCD types, this is the main key. Like first is the join, second uh, merge or merge means update or insert. This is the two operation only, right? So in SCD1, direct updation and insertion happen. Okay. In SCD2, old data will not update it. Data will not update it. Only effect end date will update. Earlier end date was in master table. What was the end date earlier for SCD2? This is new data. But before this data was not there. This 2 was not there. This is old. It is after SCD2. So here it was inactive active at the time with high rate, right? This was the thing. And when delta load came today means this is the delta load. It came on today's date 02. Right. So after joining, what operation we will perform? After joining, we will see that this C101 is common. So after inner join, this will become as changed data, right? Its location is changed. So what we will do, we will what is that? Yeah, old data is as it is. You can observe here. This data is as it is. Data we didn't touched. Only end date we changed from high to today -1, and flag we have changed from active to inactive. So in SCD2 we don't update the data. We update just end date and flag. Then how we do new this updated, what we do for this latest record? So history data is end date updated, and latest data will be reinserted as a new. Okay, so this 2 record was not, you can observe the surrogate key 2 and 3, 102 103, it was not there in the old data. Only
Like in this
S101
case, we will generate the surrogate key and then do the joining, right?
reinserted. No, joining is in starting only. Joining in is starting only. So like here joining will happen. After joining,
Okay.
this is operation, insertion operation. So for this data, updated data as well as inserted data, For both of them, we will combine them, and like for both of them, both of this, we will combine them into the not from here directly from delta, but after joining, change will be detected, which data is changed and which data is inserted. So means newly inserted. So newly inserted data, we already know that new surrogate key generated, it will be inserted with the end at high and flag active. But
So in the
updated
joining,
data,
the key would be all the columns, right?
yes, key will be this customer ID column for dimension. Customer dimension, customer ID column. This
So
is the
only
common.
if the customer ID is there,
Hmm.
if it is an inner join, right? Or what type of join it will be?
Yeah, join, inner join it will be. And if you do inner join, so you can observe here the customer ID is the common column. In this two table we will join. This is the history table and this is the new table, delta table, CDC table, also called delta
Okay.
or CDC. So in that, these two will be joined together, and that time we will see that C101 is the existing customer and its location is changed. This flag change C will be detected. Yes, its data is changed. That's why it will be processed further for updating the end date. This update query, it will update just to the end date and to today -1 and flag to inactive. It will not update the data like SCD1. And then this data, this updated data will be again go here, again go here and combined with that newly inserted data. Newly inserted data is C102 is coming and this updated data is coming. Both will be reinserted as a new. So this data is also reinserted. This also reinserted with new surrogate key and ended high flag active. Like it will reinsert it like it was new, like that. But after first is updation will be done, then insertion operation will happen. So join happen in starting only. After joining only the operation perform merge, update or insert. So join and merge. SCD operation means join and merge. That's it. Join master and delta, detect the change. As per the change and as per your method SCD1, then merge accordingly. SCD2, then merge accordingly. In both SCD1 and SCD2, joining is same. Detecting the changed data and newly inserted data. For that purpose, the joining happen. Join is for CDC capture. Okay, like
Okay.
CDC means update, changed and new data capture purpose. Because suppose 1,000 customer visited today, if we will dump directly to them, then most of this customer doesn't change their KYC daily basis, phone, email, location. So there is no use to send them for merge operation. So that's why we detect change here itself. Only changed data and newly inserted data will be captured, and that will be go for further operation. Merge is a operation. So merge into master with appropriate operation, appropriate merge operation as per SCD type. Okay, so the main difference in SCD 1, 2, 3 are this operation only. This thing is same for SCD 1, 2, 3. Capturing is same. Right. So yes, now the dimension all represent like this example. This example is given here. Like New York is early location. Now New York become ended high. Ended was high earlier or null or something, and it was become today -1 and new row inserted with. It's not that much clear here, but what I have explained. Any question in that how the things are changing at this time? I'm not explaining you detail merge operation. Okay, you can just understand how SCD2 implemented. Like this was the data before SCD2, and when the delta load detected, there was changed and this is changed data, and this is new data. So it has implemented that in this manner. Our like existing data was only ended and flag updated, not the data. In STD1, data updated. In STD2, data will not update, just flag and ended update. And the changed and newly inserted both will be reinserted as a new. That is the main thing. Is it clear? Is the theory is clear?
Yeah.
I will ask on this Friday or Thursday. I will take, okay, because
Sure.
yeah, Thursday I will ask all these concepts. So prepare yourself well and explain them. Yeah, with example you can explain, or in interview also they are not expecting you to mug up anything. Just understand and take example, take pen and paper example you write, explain by those example.
Yes, yes. Got it.
Then what is the advantage of type 2? To allow accuracy, all historical information is there, right? That for backtracking, like which location it was staying from, which time to which time, all these tree is there. But disadvantage is it will grow, a table will grow very fast, and in case where the number of rows for the table is very high to start with, storage and performance can become a concern, because data will be increased, so storage and performance will be issue. So for those columns for which the history is important to track, and generally for most of the column it is important to track, they maintain in SCD2. But there is for this drawback is there for resolve. What is the resolve or solution for this drawback? It will cause performance issue if it will become very high. Like, and sometime a customer changed the location in last 10 year, around 3, 4, 5 times suppose in every 2 year or like that. So there is no use to maintain high long back history. That is also there. Like latest 3 location they can maintain. Last three location changed in last 5 to 6 5 year, whatever location changed they can maintain that. But before 5 year data, that become no use for prediction. Like, why they maintaining historical data? For predicting the future, they are seeing the past, or for predicting the future, for generating the report based on past. One purpose is that. Another purpose is for security. Like if any person claim anything, they can detect that data. So for those data which is very important for security perspective, they will maintain in SCD2 only, because that is need backtrack anytime. A person's history, 50-year history also need to be maintained. So they maintain those secure data, they will maintain in SCD2. Okay, but those data which is just maintaining for future analytic purpose, that is not to maintain more than 5 year, is okay. So for that data, what they will do, they will either purge that data, purging the old data older than 5 year or older than 10 year. That is also come in SCD3 only. Purging the either in type 3 there are different method. Either you purge the old data timely manner, like in every 5 year one cycle will, or one operation will go that will purge the all historical data. For example, a particular students or the job person, like they apply for the jobs, and after applying for jobs in some company, suppose Capgemini or IBM, Capgemini holding their data in their database, they holding their information. When they are filling the form, the CV, all your detail, they are hold there immediately. So on this particular time limit, if the person has gave the interview, so if that interviewer is crossed, okay. If not crossed, then they will not allow him to reapply for same post within 3 months, or in same company within 3 months, like that some constraint is there. So how it happening? After 3 months they are purging all the data, then one can reapply. Either
Yeah.
purging, yeah, secure data will be soft deleted, but unwanted data will be purged. So like that they are maintaining that in type 3 manner by purging the old data more older than 3 months. Now type 3, how they are implementing? either one way I told you purging. Another way is also there. Don't maintain effective date end date. Okay. No need to maintain surrogate key also. No need to maintain any STD2 column. Just to maintain one extra column or two extra column. One extra column is just you want current and last. Current location California, previous, not last, current and previous or current and starting, depends. In telecom communication, when I used to work at AT&T, they used to maintain starting status and current status. That was, but here in address case, they maintaining current status in, it's in California, and last location, New York. So current and last, that is also possible. So this particular data is called type 3 because they here there is no effective date ended surrogate key, just one extra column. Original state or last state. It's depend. Original state also can be maintained, or from starting point. I don't know, starting and current, or last updated and current, whatever is needed. So only two columns. So how to implement that? That is also some methods are there by that can be implemented. First, joining is same. After that, merging operation will be different. That's it. Merging operation, this this will be updated. That's it. This particular will be updated with new one. New one, not new one. Sorry. This will be updated, or suppose if they are storing the last and current. So where is SCD3 here? If they are storing customer ID, customer name, location, last location, and current. That is one case. And origin, like in starting, what was the location? So start location and current. This is another case. So what the stakeholder want according to that? If they're maintaining this, then they need to change like C101 name, last location, current location. And on today's date, we received the data that it has again changed the location to ABC has changed location to California to Pune, suppose. Okay. Now what will happen here? So this updation, how joining is okay. Joining will check. It will join. It will check that okay. The change is captured. So this record is changed. This is old. This is new. It will give you. Now what updation you will do? So this last record, last location will be replaced with current location. Last location equal to current location. So this will become current last now, and current will become new one, like this. So this is merge operation will change to update master, update table name, update table name, where ID equal to, right, given ID C101. In our case, I will write C101 for your convenience. And set update table name, set last location equal to current location, where this is it. So after this query, both will become California. Okay. After that, one more update will happen. This is one update. After that, one more update. Update, same thing, master customer table, set current location equal to new one. Okay. Yeah, it is from new table. In SQL, it will be difficult, but in Ab Initio, it's more easy to take the data from the delta. So delta tables data like delta current location, I will say, just for your understanding sake. That where customer ID equal to the detected one. So this kind of merging will happen here. Insertion will also there. If there is new customer, then it will be inserted. New customer. insert query will be run. Okay. We will try to see this example also in SCD3 in ab initio. This is simple example. We'll see that. Start location, if this is the thing, then what will happen? Then this this data is same. Okay, only this is another case.
One doubt. This merge and update both are like different queries or only in same single query?
No, merging means updation insertion. That's it. In Snowflake Cloud, they use merge query, but in SQL, they use update insert query. And this is rough query I have written. Here's many thing will come, like you are taking data from this is another table. So some subquery or some particular you need to write. If you want all operation in one query, then you need to write stored procedure for that. Like stored procedure in that join first, then take the data from delta and then do according updation or insertion. So it will go big stored procedure in SQL. We are not going in deep in SQL for ab initio. In a Snowflake purpose, we go deep in SQL also, stored procedure and all. And in that merge operation is there. In ab initio, we have to drag and drop and do by graphs. So that is more easy to understand. When we will implement it with ab initio, it will more easy to understand. So is it okay, or what you asking? Come again.
No, actually, I'm not aware of this queries, list merge and update that you have written down
Merge,
here.
merge is just it is not query. It is not query, and this is not complete SQL. It's just a rough coding I'm doing, rough coding. Okay, in this SQL, it will not work because here delta, this data from where you will bring, right? And merge is not anything. It's just an operation. And for currently, you can write like this. SQL we will learn separately. In that we will see all update query we will see, but not SCD2. Only basic update query, basic insertion, and some more operation we will do. We will implement this thing in ab initio for updation purpose. In SQL also, if you want, I will show you this. Merge is not the SQL query. Merge is not SQL query. Okay, merge keyword is not in SQL. Only in SQL the merge is there, but that we are not discussing at this moment. I will show you by stored procedure up to some extent how much we can do. Okay.
This
Is it clear?
SCD types, we are going to see in ab initio as well, like in ab initio.
Yeah, in ab initio we will do complete implementation of SCD 1, 2, and 3.
Oh, okay. Okay.
Okay, and for SQL also I will try to implement little bit by update queries. We'll see how much possible. If we will go till stored procedure, then we will do SCD2. Or otherwise, just SCD1 I will show you by SQL query. That is simple one. By ab initio we will see all. Then SCD3, what I was writing here. Yes, this is another case, like start location is there. In that case, start location is same. We are just updating the current location. So it is more and less like SCD 1 only. Just California will be updated with Pune. Starting location is same only. SCD3 also I can show you by SQL. This particular mainly. This easy. This one is not difficult. It's easy. They're maintaining starting location same which was in starting dump, and then current location is only getting updated every time when new any change happen. New data will be inserted as new. Okay. Then is it clear SCD 1 and 2 and 3? All three is clear. The theory mainly basic understanding of what happening in
that's
SCD
clear.
1, 2, 3. in one line, if I will ask, then type 1, you can say that in type 1, only latest data maintained. Type 2, latest plus history. Type 3,
Latest
partial
plus recent history.
partial history, you can say. This is one way to maintain recent. Another way is purging old data. That is also there. No? So in that, type 2 is only there, but purging is there for old data. That is also comes in type 3.
Yeah.
So 3 we have discussed, then should only use when it is necessary for track history change, and when such changes will only occur for a finite number of time, like for a fixed number of time frame, you want to maintain history. In that case, SCD3. Then there is SCD6, that is a combination of 1, 2, 3. Type 1, we overwrite, or current 2 is for maintaining both, and 3 is for maintaining only partial. And if we have some kind of architecture in that all three kind of SCD types are visible, that is called hybrid architecture. In that some dimensions are following 1, some are following 2, some are following type 3 implementation. So all three implementation you are doing for different dimension. That structure is hybrid. Or in some SCD type also they create hybrid type of some columns are like in customer table itself we see customer phone number suppose is type 1, customer location is type location, or location can be type 3, and customer name, if name is changed, or important like passport number is changed, important information, old passport number is not needed, but location of the office location is changed, and we need to maintain that entire history. So those all things will be maintained here, or birth date or name is changed. In that case, that is security purpose, those information. So SSN number changed, or a particular secure information change. Those we will maintaining in SCD2. So same dimension, customer dimension. Some columns are type 1, some are type 2, some are type 3. That is called hybrid dimension. Hybrid kind of dimension change. Then, yeah. So that's it for SCD type. That much is enough. SCD 0 means the dimension which is not changing anymore. Those dimension is called SCD 0. Like example, can you think and give any example of? We have seen customer, product, time, store, 4 dimensions. Out of 4 dimension, which can be type 0?
Type 0 is customer ID.
Customer have how it can be type 0? If customer can change his phone number, email anytime.
No. You're asking about customer type 1 or type 0?
Type 0.
Type 0 is which is will not be changed, right?
Will not be changed frequently. Once in a year can be changed, or once in a 2 year, 5 year, or 10 year. Once, like in one dump. That is also not depending on any input data like that. Time related dimension, right?
Sorry.
What time dimension? Think on time dimension. What time dimension holding? It's holding time ID, month, year, date, maximum hour. Okay, not more than that things. So time ID is about T101. 101 means suppose first month of 2025. This is day. So January 1st, 2025. T102. It's first month 2025 2. January 2nd. January 3rd. Like that you can in the time dimension, one time you can dump for 10-year data. Automate it. Dump a 10-year data in this. Will it change anymore till 10 years?
No.
That's all. This is type 0. This kind of dimensions are type 0. Similarly, that junk dimension status we have seen, that is also one-time dump. That is not going to change because they are not dependent upon the users. They are fixed. So they are type 0. Customer dimension can be type 1, 2, or 3. Product also, state or store related also. Those kind of dimension can be 1, 2, 3. They are changing.
Yeah, how
Okay,
many
so
SCD types we have? Like up to 6 or up
yeah,
to 3 only?
no, actually, if how many types we have, then 0 is 1 2, 3 right? There is a 4 also and 6 also. So 6 is the combination of 1, 2, 3. That is 6. And 4, type 4 is also there. In that we maintain, that is not in ab initio. In that type 4 we maintain this thing, main table separately, and that means history separately, latest separately in 2 tables.
So we have only mainly 0, 1, 2, 3 for the ab initio perspective.
0, 1, 3 and hybrid 6 also there in ab initio, but it is going more complicated. So we will not implement that. In ab initio, we will 0 is already no need to implement. It is just for understanding sake. Then 1, 2, 3 we will implement.
Okay. For interviews as well, they will only ask like 1, 2, 3 only, right?
They ask types of dimension. They ask SCD
Okay.
types. You can explain all this. And if they ask implementation, you can explain 1, 2, 3.
Okay.
So far, with an experience, they won't implement 4 and 6 in anywhere. So most of the implementation, they'll ask about 1, 2,
6
3
is
only.
also there. In banking sector, 6 is also there. There is a huge databases are there, data warehouses are there. They're maintaining 6 also. But that is just a combination. If you know 1, 2, 3, you know 6 also. Like in customer, same dimension. If some column, like phone number column is implemented as per SCD1 and address column implemented as per SCD3 and other columns, other important column. Okay, not all columns, generally 4, 5 columns only they maintain their data. They implemented as SCD2. So this is called hybrid because it is having all 3. So customer dimension is hybrid now. That's it. So we will see different separately for 1, 2 and 3. You need to filter few more things like column wise and implement 1 for phone number column, 2 for the other column, 3 for that is hybrid. So this is also there in real time. In projects, big projects, they implement this. But in interview, they don't ask you detail of this. Because here also you need to implement 1 only, 2 only, 3 only. There is no new thing. So they will ask process, how to implement SCD 1, 2 and 3. That only they ask. If they ask hybrid also, you need to explain 1, 2, 3 only. Clear?
Yeah, clear.
In 4 is not there in ab initio. It's there in Snowflake Cloud. In a Snowflake Cloud, they maintain separately. Then these are the assignments like what is facts or measures, fully types of facts. Then what is the types of dimensions? They ask this many times, the degenerated, junk and confirmed dimension. Types of factors. What is factless, factable? What is SCD? Explain. Explain the theory. First, just explain theory at current time. When we will implement, then more questions will be formed. And then what is factless, factable? These are common interview questions, perspective assignments. So you can maintain the notes of that. If anything is not clear, you can ask. This things SQL part actually. SQL we are going to see from tomorrow. This type of question also asked in interview. I just I'm referring, like I'm taking these notes from previous page so that the writing time will be saved. That's it. So some new things also there. So we will cover this in SQL. Some person might have asked what kind of question form. So I have explained that this kind of interview question is asked. That's it. How to implement in SQL. So we will do this practical later on. Upcoming topics in our case, it will be like entire SQL we need to start from tomorrow. Okay.
Yeah, thank you.
Okay, guys. So 1 to 3 is implementation. Don't go at this time. Just understand theory very properly, because during implement is if you explain implementation also in interviews, they try to make you confused by asking different things. If your theory is not, foundation is not strong, people get confused, and then they go on deep dive in this. Like in SCD2 itself, they used to ask what you will update. If some customer is there, he was staying in Bangalore, he changed his location to Pune. How you will implement in SCD2? They ask directly. You need to tell, they are waiting for you to explain. There are 3 columns we will maintain as a SCD2, like surrogate key, effective date, end date, and flag. And the effective date will be there, like his existing location Bangalore, right? So might be some effective date will be there, some post 2000 January 19 or like that. Until end date is high 99, it will be there. High date will be there. So now what we will update, we will not update the data Bangalore location. No, in SCD2 we will update only end date to today -1, and we will reinsert the Pune location as a new surrogate key, new effective date, that is today's date, end date high, and status active. That much you need to explain them. If your theory is clear, you can explain this much.
Yeah.
Once, see, even if new project comes, what we do, we used to understand the document theory properly. Then we take a pen and paper, we write the code and structure, how to implement that code. And then we open the graph, and then we analyze everything, and then we implement that. Right? Directly, implementation or process is not, first, the logic should be clear. Then only implementation will be fruitful. So, right, guys. Please make the notes. It's very important. All the assignments, whatever is provided, it's interview based. So make the notes. You can send in the group for checking, and make the installation also done. From tomorrow we will start the SQL. Okay,
Yeah,
so
sure. Thank you.
bye everyone.
Thanks,
Bye.
Vasudha. Thanks, Anand. Bye.
Thank you. Bye.
Yeah. Okay.